the new words you heard in that story? Lane? Go ahead. Octagon? What do you know about an octagon? 8 sides, 8 angles. I'm just going to write, that's what I'm going to use for angle, okay? I don't like to write lots of words. Geometry is also something that you use lots of short forms for. Drew, hexagon. What do you know about a hexagon? Yep. 6 sides and 6 angles. Evan. Decagon. What do you know about a decagon?
It has 10 sides and 10 angles.
Okay, how can you remember decagon as 10?
Because a decade is 10 years, so a dec, it gives it away because it's like a deca. So it's decade.
A deca means 10, right? Yeah. Decade?
Yeah, and I noticed in triangle, it's like tri and triple.
Sorry, Amelia. A nonagon. What's a nonagon? Nine sides, 9 angles. Willow. Quadrilateral. That's a toughie. What do you know about a quadrilateral? Levi?
It has 4 sides and 4 angles, and you can remember that because quad is a short word for 4.
Quad is a short word for 4. Thank you. Anything else? So we've got a 4, a 6, 8, 9, and 10-sided shape. I feel like we're missing some. There is a 7-sided shape. What's it called? What is it called? Jake?
Pentagon.
Not a pentagon. Heptagon.
It sounds like
Heptagon. And one more. We're missing one. Harley? Yeah, what's a 5-sided shape called? You're right. So we know a lot of words. So let's think about our learning goal. If we're talking about sorting shapes, we can sort shapes by their side, by the number of sides they have, or the number of angles they have. So, oops, sorry. How are these shapes the same? I've got 4 shapes on the board. How are they the same? Excuse me? How are they the same? Garrett, how are they the same?
Not every shape has a point. Well, all the ones on the board right there all have they all have an equal number of sides, or doesn't?
Okay, so for every, I hear what you're saying, Garrett. Each shape have the same number of sides and the same number of angles. They all match. So this has 3 sides and 3 angles. 3 sides, 3 angles. This has 4 sides, 4 angles. So for every one, the side matches the angles. So I'm going to write that down. Side equals the angle. Okay. Levi?
They're all not curved.
They're all not curved. Yes, they all have an angle. Yeah. A corner. Do you know what we call those corners? You might have to remember to grade 2 because I know you learned this in grade 2. What do we call the corners in a shape? Jake?
Vertices.
You're right. A vertex is 1. So one vertex is bigger, this vertex is bigger than that vertex. And when I am talking about all of the vertexes, I have to say vertices. It's plural. So they all have vertices. They all have vertices, they all have shapes. What do you notice about the number of vertices, Jake? If it has 3 sides and 3 angles, how many vertices does it have? Jake? 3. If it has 5 sides, how many vertices does it have? 5. So the sides equal the angles equal the vertices. Okay? How are they different? How are these shapes different? Levi?
They all have different sides and different angles.
They do. They all have different sides and they all have different angles. So that's why we call them different things. We have a triangle. We have a trapezoid, a hexagon, and a pentagon. Okay. So just a couple of things. This was a new word. A polygon is a two-dimensional shape that's made of 3 or more straight lines. So, Evan, what is a polygon?
Polygon is something that made up of 3 or more straight lines.
Yeah, yeah. So can this be a polygon? Why not?
It does not have 3 straight lines.
It does not have 3 straight lines. A triangle is a polygon. That's right. Okay. And parallel lines. We know all of these words now. Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, vertex, parallel lines. I haven't talked about that yet. There's my definition. I want you to read it first. Eyes are here. Parallel lines. I want you to read that, and I want you to think about it. Who can tell me what parallel lines are? What are parallel lines? Taryn, I haven't heard from you. There are 2 lines that are the same distance apart, and there's something else that's really important. Because they're the same distance apart, they will never, ever
Be odd.
if they're the same distance apart, and they will travel the same distance apart for infinity, they will never, ever, ever, Jake, what will they never, ever, ever do?
They will never touch.
They will never touch.
You could have everyone drawn up until everyone dies and they never touch.
They would never touch. They never cross and touch each other. So they're always the same distance apart. So a parallel line, if I go back to my shapes, if I think about this line and this line, are they parallel? Sophie? Why not?
They aren't, because even though that they are touching from the sides, one's bigger than the other.
And a parallel line will never, ever, ever touch. So there are two lines that are the same distance apart. So looking at those four shapes, is there a shape there that has parallel lines? Is there a shape there that if you continued the lines forever and ever, they would never touch? Harley? The red one. Who can remind Harley what the red one's called? We know two names for this. Reese? A trapezoid. And what's another name for it? No, not a pentagon. A pentagon has 5 shapes, 5 sides, 5 angles. It's a trapezoid, but it also could be called a Levi?
A quadrilateral.
Thank you, quadrilateral. Okay, so where are the parallel lines in the quadrilateral? At the top and at the bottom. Now, parallel lines. I can mark on my shape a little arrow that's telling me that those are traveling in that same direction and they never cross. These lines that are opposite, if I drew them and I drew them forever and ever and ever, I extended them, those side lines are not parallel. Because what happens when I continue and draw them forever? When I extend them in the shape, what happens? Harley? They join, so they're not parallel. So those are not parallel. Is there another shape with parallel lines? You almost have to visualize. You have to track the line going down below the shape. Is there another shape here that has parallel lines? Sophie?
I think that it's going to be I want to say it's the pentagon.
The pentagon. This is the pentagon. Pentagon, how many sides does a pentagon have? 5. Okay. So let's look at opposite sides. What side do you want to look at?
Both of them are going towards
These ones? These ones? Are they parallel? No.
But you did draw something that is parallel.
Cooper, what do you want to say?
hexagon.
You think it's the hexagon. Which sides in the hexagon are parallel? The top and the bottom, so I can mark that. They're parallel. This is parallel to that. Are there any other parallel lines in the hexagon? Lucy? This one and the one across from it. And I have to mark those differently. Why have I marked them with 2 arrows? Lucy? I've already marked 1. That's right. And are there any other parallel lines in this hexagon? Sophie? Yeah. And I've marked 2 parallel lines already. I've marked one with 1 arrow. I've marked the second one with 2 arrows. So what do you think I'm going to mark the third one with? 2 arrows? 1 arrow. If I mark it with 1 arrow, that's saying that this is parallel to that. This line is parallel to this line. Is that true? No. So I can't use 1. If I use 2, then that's saying that this line is parallel to this line. Is that true? No. So I can't use 2. What do I have to use? Thank you. 1, 2, 3. 1, 2, 3. And notice that my arrows all travel in the same direction. Well, excuse me, you're arguing. These 3 arrows, they're pointing up. So these 3 arrows are pointing up. I can't draw it with 1, 2, 3. I keep them all the same.
They're going the same way all around.
Mm-hmm. So now,
There's still one in there. Yeah. There's still one in there. Yeah. I see one. Yeah.
another parallel line?
Yes. Yeah.
Where?
On the pentagon.
On the pentagon. Where on the pentagon?
Can I come up? The top one.
So if I extend this line and I extend this line, are they parallel?
No, you want to take it kind of right. I'm the
Garrett?
size. No. Come on.
No. So same,
Because it's still attached.
Logan, the sides, if I extend this line, what happens?
The side's going up.
Are they keeping the same distance apart?
No.
What's happening as I'm going out?
Oh, and they're going up.
The distance gets bigger. This distance is not the same as this distance, right? So that a parallel line, they stay the same distance apart.
Okay.
It's like a railroad track. When they built a railroad track and they started in Newfoundland, those tracks are the same distance apart in Newfoundland all the way across Canada to the British Columbia. They don't change. They don't change the direction, the distance between them.
Or else the train will go off course.
Okay, so we are going to move the shape letter into the chart. So shape A, this is shape A, it has 8 sides. So we're going to move A to the column. B, B